Hello, hello, everyone.
Hello.
Hi, there it is. So today we're going to work on Chapter 4, Section 6. This is talking about isosceles and equilateral triangles. First couple vocabulary words for this section. The first one is legs of an isosceles triangle. I will be color coding these today as we move along so that it's easier to follow. The legs of an isosceles triangle are the two congruent sides of our isosceles triangle. We'll draw that in a second so you can see what they look like. The vertex angle is the angle that gets formed, bless you.
Hi.
The vertex angle is the angle that's formed by those two legs. And again, we'll draw it here in a second so you can see what it looks like. Yes, ma'am.
What do you mean by the two legs?
Ah, great. Let me get through base angles and then we'll draw it all together and you'll see it and it'll stick. Okay, thanks. Base angles. The base angles of the isosceles triangle are going to be the two angles that are opposite the legs of the isosceles triangle. I think I misspelled a word in there. Sorry. Two angles opposite the legs of the isosceles triangle. Let's do our drawing. Draw for me, please, a triangle. Do your best to make those sides as straight as you can. We know this is going to end up becoming an isosceles triangle. You don't need to bust out the ruler and make sure those legs are the same size. Just kind of YOLO, do your best. We have two legs that are congruent to make an isosceles triangle. These congruent sides are the legs. This side and this side are the legs of our isosceles triangle. According to our vocabulary, the vertex angle is the angle formed by these two legs. Here are the legs. This is the angle that gets formed by them, and so that is your vertex angle. The base angles are the angles opposite the sides, the legs. So here's one leg. Opposite that leg is this angle. That is one of the base angles. Here's the other leg. Opposite that leg is this angle. That's the other base angle. If you're writing in colors like me and you've got enough colors, go ahead and color code. If you're not writing in colors, please feel free to label those different pieces so that way you know which is which. Did this answer your earlier question? Yes. Let's talk a little bit more about isosceles triangle. We're going to use those vocabulary words from above to fill out the missing pieces. An isosceles triangle has two congruent sides and they're called the legs. The angle that's formed by the legs is called which angle?
Vertex angle.
Gorgeous. It is indeed the vertex angle. My pen is not happy about writing on a wet highlighter. The other two angles are called? Yes, ma'am. They are indeed the base angles. We can prove a theorem and the theorem's converse about isosceles triangles. We're not going to take the time to prove them just yet today, but we are going to name them. Take something to write with separate these two theorems. The top theorem's name is the isosceles triangle theorem. And the bottom one is the converse of. Now we are going to be going back to prove triangle relationships very, very soon. And so these names right here, isosceles triangle theorem and converse of isosceles triangle theorem, will be the reasons on your 2-column proof. Okay? Let's look into what these are saying so we can try to figure out how we can use them. The isosceles triangle theorem says if two sides of a triangle are congruent, that is, the legs. So if we have legs of a isosceles triangle, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in this triangle here, if these two sides are congruent, if they're the legs of my isosceles triangle, then these angles here are the congruent base angles. The converse says the flipped version. If two angles of a triangle are congruent, so if we start knowing base angles, then we can state that the sides opposite those angles are congruent. We have some legs. Okay? So the original theorem says, I give you some legs, you can say base angles are congruent. The converse says, I give you some base angles. These are where the legs are. Okay? Questions? Pretty straightforward and simple? Good. All right, let's look at equilateral triangles. An equilateral triangle has 3 congruent sides. The isosceles triangle theorem, this one here, and its converse lead to 2 corollaries about equilateral triangles. Corollary was one of our vocabulary words from Friday or Monday? Earlier this week. Basically, a corollary is like a theorem throw-up. It's like you're given a theorem, and the theorem gets chewed on, and then you think about it for a little bit, and it goes, oh, I can say this. Blah. Corollary. Okay? It comes right out. So here's what the 2 corollaries that we can say about equilateral triangles that come immediately from these 2 theorems and its converse. The first one says this. A triangle is an equilateral. A triangle is equilateral if and only if it is equiangular. Triangle is equilateral if and only if it is equiangular. So if we start off knowing this triangle has all congruent angles, we can turn around and say that all the sides are congruent. That's that converse. The second corollary says this. Each angle of an equilateral triangle measures 60 degrees. Each and every single angle in an equilateral triangle measures 60 degrees. I hand you triangle, I tell you it's equilateral, you go, angles are 60. All right, because of this corollary. In 5 seconds, I'm going to switch the page over to the examples. While you're waiting, take a look at the examples. There's 9 of them. Identify the ones that you really want for me to go over. And those are the ones that we will work on. All right, here are the 9 examples. Call out the ones you really want me to work on. I've got someone giving me 2 in the back. Thank you. And number 4. Any others? Number 5. Whispered because it was a secret. And number 8. Yeah, got that from 3 people. Number 6. Number 7. All right, that feels like a pretty good mix of everything in there. All right, let's go ahead and start with number 2. As we're looking at number 2, what do we have? What's our shape? It is a triangle. What do we know about this triangle? It might be acute, I don't know. But I've got some angles that are congruent. We can call these base angles. When I have angles congruent, I have sides congruent. Which sides? The legs. According to the theorem, the ones opposite those angles. So opposite this angle is this side, opposite this angle is this side, and the theorem says they are congruent. If they're congruent, then this measurement equals this measurement, and I'm going to write the measurements of side SV is equal to the measurement of side TV. What is the measurement of side SV? 2x plus 6 is what I was told, and the measurement of TV? 3x minus 6 is what I was told, thank you. Let's solve this for x. What should I do? Move one of the x's, subtract 6. Both of these are correct answers. Which x should I move?
3x.
Okay. The 3x is the one you want to move?
Yeah.
Okay. That's not the one you have to move. You could have moved the 2x also. But you want to move the 3x, so we're going to move the 3x. We're also going to subtract 6 from both sides. We're going to do this all in the same step. Okay? I'll use different colors so you can see what we're doing. Here's me subtracting off the 3x as you requested. Here is me subtracting the 6x. Excuse me, the 6 as you requested. I'm going to use orange here to help me keep track of where my equal sign is supposed to go. All right. 2x minus 3x leaves me negative x. These are canceling. 3x minus 3x, no x. I'm not going to write anything, but I could write a 0 if I wanted. Negative 6 minus 6 is negative 12. Now what?
Divide by negative 1.
Divide by negative 1 so that I can get rid of that negative, and x equals 12. Is this the only steps for algebra you could have taken to solve this one? No, there's 100 others.
Oh yeah.
This is just one of many. You take whichever path you like the best. Take a look at number 4. What kind of shape do we have? It's a triangle. What kind of triangle? It might be acute. I don't know till I know the measures of the angles. It certainly looks acute, but I don't know for sure. Yeah, I've got some legs going on here. See these little markings? That means that those sides are congruent to each other. That means this is a leg and this is a leg. I'm staring at an isosceles triangle. And when legs are congruent, what angles are congruent?
Base angles.
The base angles. Name the base angles, please.
A and C.
Angle A, angle C. I'm told that angle A is 6s plus 6, and so the measure of angle C is?
6 plus
Which looks like a big mess right now. But I know the triangle angle sum. The triangle angle sum says I can take the measures of all the angles in my triangle add them together, and I should get 180 degrees. Thank you. When I'm on a flat sheet of paper. Slip that in there. What's the measure of angle A? 6x plus 6, she says. The measure of angle B?
You don't know.
2x.
2x, says everyone. And the measure of angle C?
6x plus 6.
6x plus 6, says everyone. Very nice. I'm going to go ahead and solve this for x. I'm going to do that. Whoa, lights flickering. We're going to grab some like terms here. I'm putting some boxes around all the variables. Notice that I grabbed the plus signs in front of it. If there isn't a sign in front of it, I can add one in. So I have 6x plus 2x plus 6x for a grand total of 14x. That is way too light to read. All right, going to go ahead and collect like terms on the numbers. I have a positive 6 here and a positive 6 here for a grand total of positive 12. Please make sure you write a 12. Unlike me, the very first time I did this, I said 6 plus 6 and I wrote 6. Now what? Subtract off the 12, and when I subtract 12 from both sides, I'm going to end up with
14x equals
168. And when I subtract 14, I'm going to end up with, excuse me, you're right, divide by 14. When I divide by 14, x equals 12? Okay. I believe you. I don't have a calculator up here. Thank you. Look at number 5. It's a right triangle, which means the measure of this angle n is?
90 degrees.
Do you notice how otherwise it's exactly the same as in number 4? Look at the setup. Yeah. Can you do number 5?
Yes.
Do you need me to walk you through it?
No.
No, you're brilliant. Look at number 6.
The same thing.
You're right. It's exactly the same thing. Do you want me to walk you through number 6?
No.
No, because you guys are amazing. Let's look at number 7. What kind of shape do we have on number 7?
Equilateral.
An equilateral triangle, because we were told that this side is congruent to this side, which is congruent to this side. What do we know about the angles in an equilateral triangle?
They're all the same.
They're all the same. And what else do we know about the measures of the angles in an equilateral triangle?
They're all acute.
Look at the corollary for equilateral triangles. Corollary number 2. They all measure 60 degrees. Which means that
X is
6x equals 60, and as he said, x equals 10.
Oh yeah.
It's almost like cheating. But it's not, because you're using the corollaries. Let's look at number 8. What kind of triangle?
Equiangular.
Equiangular. And when we have an equiangular triangle, what else do we have? An equilateral triangle. Because the corollary number 1 for equilateral triangle says, if I have an equiangular triangle, I also have an equilateral triangle. Equilateral means all sides are equal, so this piece equals this piece. Don't think, just write it. And now I can solve for x. What should I do? Subtract 5x from both sides, okay? I'm going to use my orange highlighter here to keep track of where my equal sign should go. 6x minus 5x is
X.
just 1x. I don't have to write the 1, I can just write x. 5x minus 5x is
Nothing.
nothing. What symbol do we write for nothing? 0. Now I heard just x, but it's really 0x, right? I had 5 ex-girlfriends and I shot 5 ex-girlfriends and I have no ex-girlfriends there anymore, right? So 0 x's, no more x's. So just 0. It's okay for your equations to equal 0. In fact, Algebra 2, College Algebra, which is coming up next for you guys, you will be completely interested in which values of x make the equation equal 0. That's like the entire purpose of that year. Set things equal to 0, figure out what numbers those letters have to be to make that happen. Let your equations equal 0. All right, what's the value of x?
-5.
5.
Just
5.
5, because
Five.
you had to add 5 to both sides right here. Very nice.
Good job, guys.
Good job.
Proud of you.
How are you feeling on these?
Great.
Feeling fantastic. Do you need to see any of the others?
No.
All right. Thank you very, very much. Do I do the obligatory end of video subscribe for more math?
Yes. Make sure you smash that like button.
do it. Say it loud.
Alright guys, thank you for watching. Make sure you smash that like button and subscribe please. Thank you for watching.